I wanted to create another example to show how we can use the area model because I'm afraid jumping right into pattern blocks and Cuisenaire rods when it's not the predefined whole, like with the fraction circles. I think there's a disconnect. So I wanted to create another example to show how we can see the area model, right, and show this addition and subtraction in the models that we're familiar with. So what I did was I created 4/5 and 2/3. And first, let's show the addition of those two fractions, right? And actually, let's color coordinate this. 4/5 plus 2/3. So we see the 4/5 in the red, the 2/3 in the orange. So what I want you to see is just like in addition of whole numbers, that means we would just kind of put these pieces together, right? We would fill up this amount of space and think about, well, how much space then did I use from this? And so with this manipulative, maybe it's really hard to see that. But if you have them as individual pieces, like we do with this manipulative, we can see that. So we have one fraction of 2/3, one fraction of 4/5. And so we want to add them together. So let's add these fifths in here. Oh, but what I want you to see that now we're stuck. We don't know how much of this space is, and then we don't know, so clearly this whole thing doesn't fit in there. Is it a tenth? No, it's bigger than a tenth, or it's more than 1/10. Is it a 12th? No, more than a 12th. Is it an eighth? Nope, still more than an eighth, right? So with this tool, we don't have this amount of space. So that's why, we don't use these a lot, because we can't show every fraction that we might want to see. And likewise, here we go. If we were thinking about it this way, right, we said 4/5, 1, 2, 3, 4 plus 2/3, 1, 1, 2. So here we can now, with the length model, we're just comparing the lengths. We can see that it's at least 1. Is it 1.5? Nope, not quite 1.5, right? Is it 1? It's not 1 2/3, not 1 1/3. Does fourths work? No, again, 2/4 is the same as a half, right? Does fifths work? I think you know the answer, right? Why can't we find this space, right? Why can't we find how much of this total is? Yes, right? Dr. Swartz, it's because we need that common denominator of 15. This is going to be something over 15, right? These are 15ths, and that's why we don't have that option here, right? We can line up all the 12ths. They're still not going to line up. And so I'm going to clear this. But what we can see with this is, okay, we want to find out how much, right, is all of this space together. And so if we took one of the, here we go. Maybe this might help us to see, like maybe you didn't see, or maybe, we're only thinking about 15ths because we have that experience. We know we need common denominators when we're adding fractions. But check this out, right? What is this little sliver right here? What is this little sliver right here? How big is that space? How much space is that? And what I also want you to see is, like, this right here is my 1/5. So if I do this and then this, those all look the same, right? That's the same amount of space. Oops, sorry, I'm still in the annotate. So I can even, maybe that you're like, wait, show that again. So let me show that again, right? If I just have that 1/5, right? So now you're not getting confused by the other thing. Look at how much space right? This 1/3, or the slice of the third takes up of this fifth, right? This is what I mean by having one whole that shows both of these denominators. Right here, we see this little sliver. And if we can create two more of those little slivers right here and right here. It's taking this 1/5 piece and cutting it into 3 equal pieces, right? 1/5 divided by 3, or 1/3 of 1/5. And that of language means multiplication. And that's why to get common denominators, or to find a common denominator, we just multiply the denominators, right? To show fifths and thirds, it needs to be a common multiple of both 5 and 3. So we need to be able to divide 1/5 into 3 equal pieces. Or we can look at it also the same way. There we compared it to the 1/5 piece, but what if we compared it to the 1/3 piece? How many pieces are these little slivers going to fit? Oh, sorry, that one's terrible. Sorry, now you know why we use the accurate representations, right? 1, 2, 3, 4, 5, right? Or we wanted to show 1/3 piece split into 5 equal pieces. This is that rationale for common denominators. All right, I'm going to clear these. So you're like, I still don't know how to show adding yet without this common denominator idea. So, and this is why using the pattern blocks, using the Cuisenaire rods are actually going to be more helpful, because we can create, right? I don't have these as individual pieces, right? They're all stuck in this circle. When I have them as individual pieces, I don't have any way of making 15ths, right? So I can create this as 15ths. And now I can show these equivalents, right? If we look, actually, maybe I'll turn this back into just 1/5 for a second. And let's look at, right, that's 1/5. Let's look at this equivalence. How many 15ths now is that? 1, 2, 3, right? 3/15 is the same as 1/5. So understanding these models and how to show this equivalence is so, so, so important. Likewise, right? This is my 15ths. If I overlay it on top of the thirds, right? Maybe we just look at this one, right? How much is 1/3? 1, 2, 3, 4, 5, right? Exactly what we just saw when we overlaid the thirds and the fifths. So if we wanted to add these, it's just going to be clunky, right? We see we have 2/3, and maybe that's what we do. Maybe we show 2/3. Let's just put this on top, do the orange, right? 2/3 here in 15ths. Now let's duplicate this and let's show 4/5. Right? Is this the same? Shall we look? Compare? Oh, exactly the same. Now we can take these 1, 2, 3 and put them in here. Oops. I don't know if I can make these different colors. I think as soon as I change it, right? So now we see we have a whole, let's make this all yellow because it's the orange. Maybe I should have done a color that can be both of them, right? Here we see we took those 3/15 out of here, made one whole, and 7/15. Or I'll go back here and now we'll go. If we think about this, right, common denominators, 12/15 plus 10/15, right? Right now we can see, oops, right? This is the same as 12. 12/15 plus 10, oops. 10/15. Add them together. 22/15, which is the same as, right? We saw 1 and 7/15 when we took these three, right? These three right here, and we put them over there. So I want you to see how we use these tools to show adding and subtracting, to show the rationale why we need common denominators or where common denominators and those procedures come from, right? It's this idea of finding these equivalent fractions, finding one whole that can show both denominators, right? This whole is able to show fifths and it's able to show thirds. And that's really important, right? Here we have fifths, here we have thirds, boom. Now we put them together. That's what adding means. Just put them together. Can you use now this same idea? Maybe I'll stop this video and make a second video to show subtraction. We'll use these exact same fractions, 4/5 and 2/3, to show subtract. Now take a minute. Can you show subtraction? And come back and watch the second video to see the subtraction.